Good evening, everyone. Welcome to tonight's webinar. We are also streaming on Facebook Live, so welcome to those of you guys that are there. My name is Amy Chow, and I will be the moderator for tonight. Our presenter tonight is Karen Greenhouse.
Hello.
We are going to take a look at geometric constructions. For the sake of webinar quality, we're going to keep everyone muted and all videos turned off. So if you have any questions during the webinar itself, feel free to send out a chat to everyone in the webinar that's joining us today, and I will be able to either respond directly through chat, or we'll ask Karen to stop and answer the question out loud. So if you don't have that open yet, go ahead and get that open. And then let me introduce myself a little bit more and let Karen introduce herself as well. So as I said, my name is Amy Chow. I am the Training and Product Manager at Casio's Education Division. I've been at Casio for the last 10 years, working closely with schools, districts, and conferences to coordinate workshops, as well as working with our development team on calculator updates and improvements. And now Karen.
Hi there. So I want to just say that you guys are our guinea pigs tonight. We are trying two new things. One of them is closed caption for when I'm talking. So hopefully that will not be too distracting, but we're testing it out for some future webinars. And then also we're live streaming on Facebook. So welcome to everyone there. I'm Karen Greenhouse, and I am a consultant for Casio. I've been doing this. This is going on my 6th year. And I am also an adjunct professor at Drexel University. I teach in their math master's program. And I've been a teacher for over 30 years, and I've worked in lots of different arenas. But my big focus, my doctorate's actually in technology and mathematics. So I am very obsessed with using technology, dynamic technology in mathematics. And so that's why I'm pretty excited about working with Casio, because I get to work with lots of different kinds of technology. But we're working with Classpad.net tonight, so I'm going to kind of switch my screen. And I know many of you have been on our webinars, so I don't want to repeat myself too much, but for those of you who are new, Classpad.net is a free dynamic math software. And basically, this is the landing page, Classpad.net. And you don't need an account, you can just start exploring, and we're going to actually start that way in a little bit. If you want to actually save anything you do, if you're playing around, you're like, oh, I love this, or you find an activity, you do want to create an account. I highly recommend creating an account, because then everything you find or do is saved. If you just play, it doesn't know where to save anything. So creating accounts easy, it's all free, and it's free forever for students, for you. So it's a great tool. And I know a lot of teachers are working remotely now, having to distance learn. So this is an amazing tool to be able to use with your students. We've had some previous webinars already that have talked about how to share papers, how to create homeworks, those types of things. So, and we're going to have some in August that are specifically designed for helping you think about distance learning with students, if that is how you end up having to teach. So just be on the lookout for those. So today's focus is on geometric constructions. So I want to go in, so this is what Classpad looks like when you go into it. It's kind of a blank piece of paper. And for those of you not familiar, when you click anywhere, you can then decide what kind of math you want to do. And this is what I love about it, because you're not stuck to having to graph or having to do geometry or having to do something very specific. You get to choose. So you can do calculations, you can do graphing, you can do geometry. Today's webinar, we're going to basically stay in the geometry sticky, but there's data that you can do, finance, sequences, and text. So I'm going to pull up a text here. So this is a sticky. All of these things are called stickies. So this is a geometry sticky. You'll see the geometry functionality down here. These are the tools, and we're going to be exploring a lot of the construction tools today. But each sticky is basically like a piece of Post-it paper, and you can arrange your paper however you want. That's why we call them stickies. You can move it, arrange it, make your paper look the way that it wants. So when I'm creating things for my students, I tend to write directions in a text sticky, and then I make another text sticky with a different color. I can change colors right here to have a place for them to respond and write down their answers. So it's a whole entire dynamic worksheet, if you want to think of it that way. So I want to focus on circles first. So I'm just our focus here. I'm going to ask you all a question. What do you know about, what is one thing you know about circles? And if you can just, so just type something you know in the chat panel. We're gonna try to use the chat panel, do some communication here, which is what, if you're working with students, you know, you want them to, you ask a question, you want them to respond. So hopefully people will respond. Just one thing, they are round. Okay, okay. Thanks, Amy, very helpful.
Welcome.
Anyone else? What's the most important thing you think that students should know about a circle? How about that? It's round, the set of points. Okay, thank you, Tom. The set of points is equidistant from a fixed point. That definition is key to geometric constructions. So do I have any geometry teachers that are here? If I do, maybe everyone who is a geometry teacher do a quick yes, no in the participant panel, I guess it is. I am a geometry teacher. I've been a geometry teacher forever, and it's my favorite subject to teach. And circles and constructions, circles are incredibly important to constructions. And by constructions, I mean compass, straight edge. And it's something that I think a lot of teachers skip over these days. And what I'm trying to emphasize in this webinar is that it's so important to understanding relationships in geometric constructs and helping students develop geometric proof, because it is no measurements, it's really using the properties. So that's what the focus is. So why is a circle so important? Well, it's that key thing right there that many of you have already put up. Thank you, Patricia. All points are equidistant from the center. So what does that mean? So over here, this is a geometry sticky, and I have a point, a blue point and an orange point. And they have a distance, right? And this little X right here lets me change the distance between those 2 points, right? So whatever this distance might be, all the points that are that same distance away from the blue point are going to form a circle. And that's what we tell students. We tell them this is the definition of a circle. It's all the points equidistant. Well, what does that mean? Students get very confused by that. So I'm going to kind of show you a way to kind of help introduce this, because this understanding is foundational for constructions, is understanding what a circle actually is. So I could make a segment. So this is now just my straight edge tools right here. Notice I'm not using any measurements, and I've chosen a segment, and I'm going to connect these, right? So that is now a segment. This segment is the distance between blue point to orange point, right? And I'm going to select the orange point. And over here, so I got some tools down here with my geometry, and then in Classpad, this little arrow over here, and if I move this sticky a little too far, it'll switch sides, because it kind of understands where you are. But when I click this, these are the optional things I can do when I select something. So I want to go into this thing, and you'll see it says trace. I've selected the point, and I'm going to trace it. And what I want to show you is where that definition is coming from. So we tell students a circle is the set of all points that are this distance away from the blue, the center. So watch what happens when I move, and I'm going to move it really fast at first. And so I don't have all the points. I have some points, right? But if I were to take a segment and connect from this point to this point, and from this point to this point, what I'm telling students is that any point that is this distance away is the definition of a circle. So notice as I moved my traced point, it was kind of showing the path. I'm showing them what I meant. And if I went really slow, you can see that my trace fills in and actually looks like my circle. So it's helpful to, this is using dynamic software to kind of show students what this means. And if I change the distance of the circle, of that point, and I probably should have turned my trace off. Now my point's over here, so it's a longer distance. So now if I move this point around, I now have a different circle because the distance changed, right? So the distance, that radius that we then define as a radius, is the distance from the center to any point on that circle. That is a key foundation for constructions. So I just wanted to emphasize that because we're going to be coming back to this a lot. So next thing I want to do, and I think my screen, maybe if I pull my screen up there we go. And by the way, this is a hide show button. I actually created this point on the circle first and then hid the circle so that it would, only go in that motion. So in the geometry sticky, you can do things like hide and show buttons. So I'm going to scroll down. Actually, no, I'm not. I'm going to go over here. When we work with students, we want them, and when I worked with students, you want them to actually use a real compass and a real straight edge, no measurements, and pencil, right? We want them to do constructions. It's really important because it helps them kind of understand the relationships in the geometric shapes that we're looking at. So I'm going to pull up something that's kind of cool that you can do in Classpad, because I want to talk about why a compass. So I'm going over here. So this is the geometry tool. And when I click this button, I can put text in, or I can put an image in, or I can use a protractor. I'm going to go to my image here, and I'm going to pull up an image of a protractor, which I think I put on my desktop. There it is. I'm not a protractor, a compass. I'm the worst geometry teacher. I always had to think, do I mean compass or protractor? Oh my God, every time. It was horrible. All right, so here's a compass. And so why do we use a compass? Well, a compass makes circles. And what do circles do? Circles guarantee congruent segments. Every radius in any circle I draw, I know is going to be congruent to all the other radii in that circle. So I have automatic congruent segments if I have the same radius. And so what we want to help students understand is that this compass, when you open it up, you're putting your, and I'm just using, actually, I want to turn off. The geometry sticky automatically labels points. I don't want anything labeled at this juncture, so I'm turning it off so that my points don't get labeled. So we tell the students, okay, so you put your compass down, that first point marks your center, and then you open the compass. The compass opening is the radius of the circle, so we're going to open it a certain length, so that's that second point, right? And this represents your radius. So the opening of the compass is the radius that you are going to use for the circle you create. And so this is the distance. And this, any segment or that you do with that circle is going to have the same distance, right? Because that's the definition of a circle. All the points are equidistant from that center point. So why do we use a compass? Because it makes circles. And that's going to come into play. And I want to show you there's a couple different ways on Classpad that you can use circles. Obviously the circle tool. But if I want the compass tool, I want the compass to stay the same radius all the time. I want to actually use what Classpad has is a compass tool, what students technically are doing. So when we tell them to open your compass to this specific radius and then make many different circles, that radius stays the same, right? So that's a compass tool. You can't do that necessarily with a circle tool because that circle can change space. So circles are, there's a circle tool and there's also a compass tool. So I want to show you the difference. So if I use this circle tool here, and I kind of don't want to put it right on that, I could make it kind of match, but I could, if I try to move it, I could accidentally change it. So it may not match up exactly. So I don't necessarily want to use the circle tool in this case. Instead, I'm going to go to the little right arrow and under construction, the very bottom. So notice why we're in here. We're gonna look at many of these, but here's all your construction tools, all the things you can construct. So your perpendiculars, your bisectors, your midpoints, intersections. But I want to go to the compass tool. And all the compass tool is basically simulating what a real compass does, which is opening up and making a circle from that radius of the opening. So notice up here, there's a little set of directions. Select the segment or 2 points. Well, here's my 2 points. So I'm going to select the center and the radius edge, and that created a circle, but notice I can't change the size of the circle. It matches exactly the radius, and if I can do it again. I can create another one, and they'll be congruent because I used the exact same radius. So the compass tool, basically when you're doing construction with students, especially when you're first starting, and you're using this as a demonstration, so the way I would do it with my students whether I'm online or face-to-face, is they might have their own compass and straight edge, and I'm modeling with my tools here. So I want to make sure that, okay, you're going to open your compass and now make a circle and it should match, and now make another circle, they should be congruent, those types of things. So I want to start with basic constructions, and what you should do with students is really go through these first three definitely with a compass and a straight edge. Obviously, I'm in dynamic software, and I could go right to making a perpendicular bisector without having to go through all the circle stuff. But when you're working with students first, you want to actually go through the manual and the visual representation of using the circles and using the straight edge, because it's really reinforcing properties. So I'll show you what I mean by that. I'm going to start with a really simple one. Usually it's the first construction that students do. And I'm going to pull up another geometry sticky. So here's the nice thing about Classpad. I can create new things and just keep adding as much as I want to this paper. So I'm going to keep this image over here, but now I'm going to start it with a new one. And again, I want to turn off my labeling. All right, so let's say I have a segment. So the first construction students usually are given is, and I like to make the orientation different instead of always horizontal. They're given a segment and they're shown how to construct a congruent segment using a compass and a straight edge. And again, no measurements because we're using properties. So what property are we using? Well, if I'm asking students to construct a congruent segment to this, what shape do we know has congruent segments in it? There's only one. Easy shape. Well, compass is the tool that I use to make it, but it's a circle, right? The definition of a circle is the set of all points equidistant from a center point. So if I get my compass tool, so we're going to tell the students, get your compass tool, and we're going to get our compass tool, right? And they're going to open their compass to put one point on one of the endpoints of your segment, open the compass to the other point, that's your radius, and now make a circle somewhere else on your paper. So I'm going to do the same thing. I'm going to select a point for my center and a point for my radius, and I now have I have a circle, so I go off and construct my circle, and I can make this a little larger here. How about we do that? I don't know what feature they're talking about, so I kind of wanted it to go off to the side here. There. You don't want them to necessarily make the circle around that segment. You want it to over here. So I'm trying to make a congruent segment to this one, right? So here is the circle I constructed from opening my compass to this distance, right? And now I just have to get my straight edge. So with students, you want them to use their straight edge and go from the center point and cross over to the circle. And now I have a segment that should be congruent, and maybe I should even make it a different color. So I'm selecting it and going to properties and color. So this segment should be the same length as this because I use the same radius, and that is the definition of a circle, is all the points equidistant, so I use the same distance. So how could I verify that? I don't want to measure, I mean, I could measure, but with students, we want them to verify because they just used a property. I use the same distance, and so this should be the same distance as this. With dynamic software, I can actually kind of put them next to each other and show that it's the same. I'm trying not to put them on top of each other because they tend to get locked. But I can show they're the same. And students could, if you're using patty paper or something, could fold it, they put it on top of each other and show that they're the same length. But that is all based on one simple prior knowledge, knowing that circles give me congruent segments. Because if I have the same distance between 2 points, I have congruent segments because of the definition of the circle. So that's the most basic construction, right? The next one would be an angle. Construct a congruent angle. And some of you might be thinking, well, why do we go through this with students? And again, the idea is to help them have that foundational understanding of how circles are even coming into play and how circles and eventually perpendicular bisectors are so important to all geometric constructs. So I'm going to make an angle here, and I'm going to actually make it out of well, let's make it out of segments. And let's turn off. There we go. So I'm going to make an angle. And again, I'm all about trying to not always do the same orientation that we tend to do with students. So making it a little different. So here's a circle, right? I mean, a circle. Here's an angle. And I'm asking students, construct another angle that's congruent to this. So they know they have to have at least, they have to have two sides, right? So they're going to start with a straight edge, right? So get their straight edge, and I'm going to actually use a ray this time. So they're going to make a straight edge, and you know, often they make it in the same orientation, but I'm just going to do this that way. So how am I going to get this second side? How do I make sure that it's the same amount as the original angle? Well, this is where circles come into play again. So I would like to be able to use my understanding of a circle. So I'm going to get a circle tool instead of the compass right now. And so they're going to take their compass and basically make a circle that intersects both of these. So I'm going to and it doesn't matter how far I go on either, I'm going to go just a little bit. And I'm going to make this intersection point, so students are going to do the same thing. So why am I using a circle? What does that have to do with anything? Well, what do we know right away about this distance? Maybe I should label my points. What do we know about point A and point B? And let's make that one point C. What do we know about CA and CB right away? Just by doing that. All I did was make a circle. But what do I know about CA and CB immediately? Anyone in the chat panel? They are equal, right?
Says they're equal.
Tom
But
loves
he jumped a little ahead.
That's okay. So by constructing a circle, I have created two congruent lengths, right? So now if I copy that and do that over here, I know that I can try and do the same thing on this side. So I'm going to, instead of my circle, so here's the decision. Do I use the circle tool or do I use the compass? Well, I need to make sure it's exactly this distance, so I'm going to use my compass. And with students, they would use their tool and they would open it, put one end of the compass on the center and one end on either A or B, it doesn't matter because they're congruent. And now they have a compass that they have a circle that we know is exactly congruent to that one. And I'm going to move it over. I really should be changing the color here. I'm going to move it over and line it up on this ray that I did. And it should lock if I did it right. I don't know why it's not locking. There we go. So now I have another circle that I know is congruent to this because I use the same distance. And so I know that if I put a point at this intersection, it is also congruent to, I want to construct the intersection. It is congruent to AC and AB. So what's missing? Well, if I could figure out where to put another line here, with another intersection, I could figure out my angle. Well, how could I use what I've constructed? Well, this is just a distance. A and B are a distance. That's the distance that my angle is, right? The distance that it's open. So I'm going to get my compass tool again. Let's change color here. Make it red. And I'm going to do the same thing. I'm going to use my compass to measure a distance and keep my distance consistent. So I'm going to measure the distance, the opening of the angle by selecting the 2 points. And so that's the opening of my angle. Well, what did I use? I used A as my start point and B as the opening. Could have gone either way. So now this represents the distance that the angle is open. So if I put this point on this that corresponds with A, what happens? Well, my circle that I created, or my distance, intersects with this other circle. And actually, let's show you how they match. That's what I did, right? So now all I have to do is figure out what's this intersection, construct that point that they intersect, and now use my straight edge. So let's get a straight edge tool. We'll use array again and go from the center to this, and I should have a congruent angle. So notice the understanding of a circle having equal distances, and I can use my compass to guarantee that the distance is congruent and use the intersection of those circles to help me make those constructions. So the last one I want to do, I always think it's really important that we, Amy, keep me track of time because I know I ramble on. It's really important to go through these basic constructions first to help students understand where all of this is coming into play, the things that they've learned, the definitions, how it's helping them make precise geometric constructions. So the last one I kind of want to do before I get into specific shapes, and then using the shortcut tools, as I call them, all the construction tools. To me, they're, all these construction tools here, they're technically shortcuts. They are doing all of this stuff with circles in one step, like it's been programmed to not show the circles, basically. So I want to do one more, perpendicular bisector, because this one is, again, a crucial construction that interplays with everything else. So perpendicular bisector, I'm going to get a segment. And now the idea here is students already know what a perpendicular bisector is before they're getting into how to construct them, right? So they should already have gone through this. As prior knowledge, it's really important because the construction basically reinforces their understanding of what perpendicular bisectors are and the properties of perpendicular bisector. So before they get to this point of constructing a perpendicular bisector, they should know that a perpendicular bisector obviously takes a segment and cuts it exactly in half, right? And it forms right angles at the intersection. And the endpoints of that segment that has been bisected will be equidistant to any point that's on that perpendicular bisector. All of this is really important and connects to the circles. So here's this segment, right? And I know that I want to have a perpendicular bisector that I know has to be equidistant, right? So I'm going to make some circles. I'm going to use my circle tool this time. So those of you who are my geometry teachers, I know when you teach constructions, it says you want to make sure. So I'm going to construct two circles. The end points of the segment are going to be the center of two different circles. And so here's my first circle, and the directions usually when you first teach it says make sure you make a circle that's at least halfway through the segment. And the question is, well, why are we doing it halfway? Well, if we're trying to find intersections, we want, and the perpendicular bisector has to go through the midpoint. You can't stop before you get to the midpoint because then your circles will never intersect, right? I used to always teach my students, well, you just want to have congruent circles that are. So the easiest way to make two congruent circles with endpoints as centers is to just use the segment as the radius. And so I make one circle, and then I'm going to use the other endpoint as the center and make a second circle. It's more efficient, and it serves the same purpose. But you definitely need it to be more than halfway because think about it, we're trying to make the perpendicular bisector. It has to go more than halfway because you need the intersection. So I have these two circles. What do I know about them? I use the same radius, so I know they're congruent automatically, absolutely congruent. So if I click and construct their intersections, so for students, they would just put the points there. For me, in the dynamic software environment, I need to actually go to my construction and construct the intersection. So notice I get 2 points. So what do I know about these 2 points? I'm going to change my color here. Well, here's the center of one circle, right? And if I connect this center to, and actually let's use, students don't have to do this. I'm explaining what we know. I know that if I connect this center point to this intersection point and this center point to this intersection point, that those are congruent. Why do I know this? Because this is a circle and these are both radius radii of that circle, so they have to be congruent. And if I do the same thing, let's change the color, from the center of this circle, if I connect the center of this circle to this intersection and the center of this circle to the other intersection, I know that the green segments are congruent because they're both radii of the same circle. But remember, we constructed the circles from the same distance, right? So every point on each circle is the same distance, which means that the green and the red segments are actually all congruent, right? So that means this point right here, and let's label it so that will help. That point A and that point B are equidistant from the endpoints. These two distances are the same. I could mark them congruent. And these two points are the same. Anyone notice what shape I actually created right here? This is the easiest way to create a specific shape. So we've kind of done two constructions at once. Very good, rhombus. Normally you wouldn't do this to students. I'm trying to explain how we know this is the perpendicular bisector, because now I'm using the properties that I know about a perpendicular bisector to basically verify that I actually have a perpendicular. If I connect with my straight edge, so I'm going to use a line this time, and let's make it orange. If I connect these two intersections of the circle, I know that this orange line right here is the perpendicular bisector. I know this because it is equidistant from both of the endpoints of this. So it has all the properties of a perpendicular bisector. I could test that it's a 90-degree angle. I know that it's halfway. All of these things are true, and that makes it a perpendicular bisector. And I didn't have to measure. I could measure, I could verify, but I have a perpendicular bisector. So how does that help me with anything else? Well, one of the things students have to do a lot when they are, another one they have to do, this is usually on assessments, is in Virginia. Let's say I have a straight edge. I'm going to make a segment. And I have a point that's not on it, and I'm asked to construct a perpendicular. Well, it's not as easy as the perpendicular bisector. I don't have a perpendicular bisector, but what do I know? I'm going to use my circles again. I know that if I get a circle and make it circle that hits this segment in at least, oops, at least 2 points. There we go. That's what I wanted. I'm not going to do this whole construction. I just want to point out how the perpendicular bisector is a really key foundation. If I make a circle from this point and make it hit 2 spots, and we often tell students, oh, just make it hit 2 spots. Well, why are we doing that? Well, let me get a different color here just to show you. These 2 points are on the segment I was trying to be perpendicular to, right? If I get just a segment, and we have to remember to students that this little segment right here is still part of the original segment, right? So if I make a perpendicular to this red, it's still perpendicular to the rest of the segment that this little piece is lying on. But notice now I just have a segment with 2 endpoints, and I now have a point, and I can find the perpendicular bisector to it. And so this construction helps me get to other constructions is where I want to go with this. So I'm just going to I'm looking at my time, so I want to make sure I go into the actual construction tools. Here's my suggestion when you're working with students: make sure you teach them and have them actually do constructions, whether they're working with, they could be working in Classpad and using these tools themselves, the compass tool and the circle tool, but have them go through the basic things of a congruent segment, a congruent angle, perpendicular bisectors, even constructing things like a rhombus. That's a pretty easy construction. It's all based on circles, and it's knowing your properties, because constructions are an amazing way to apply the properties that they learn about shapes. But eventually, the circles become almost they get in the way of what you're trying to get into, which is applying the properties. So then that's where the construction tools of a software come in handy. You don't have to go through all the all the circles and constructions. So I suggest you start with students for sure doing it this way, because you're really emphasizing the importance of circles, congruent segments, radius, perpendicular bisectors, all of those properties. But now let's say we want to have them construct, and I used to do this with my students. We'd have a whole, their assessment for the quadrilateral unit was, and I used Sketchpad at the time, was to construct an example of each special quadrilateral, and it had to pass the drag test. So what does that mean? Well, I could, and I'm going to turn this off again, I could use my geometry tools to, make something that looks like, well, that's definitely not going to look like a square, but I'm just eyeballing it. So let's say a student says, here, Miss Greenhouse, this is my square. And maybe it looks like a square on the outside, but does it actually have the properties of a square? And so that means, can it pass the drag test? Well, no. Right now, I've made your square not be a square because you didn't really apply the properties. So they really have to know their properties in order to do constructions. So I'm going to make, let's get rid of that shape that I just did. So how would you, we're going to actually start with a square, because, no, actually, let's start with a parallelogram. So those of you who are my geometry teachers, so what do we know about parallelograms? And I'm going to use a straight edge right there. So what do we know about parallelogram? I'm trying to construct a parallelogram. So what is something I need to, okay, diagonals bisect each other. So there's lots of different ways we can do constructions, and I just want to go through some of the tools. So diagonals bisect each other, okay. Anything else? Anyone else? Two sets of parallel lines. So I'm going to use that property to start off, parallel. So here's my, let's say I have a starting, and actually maybe we should do, let's do segment, just to be on the safe side. So let's say I have a segment, and I'm trying to make a parallelogram. So I know I want another segment parallel to it. I could do the circles, but now at this point, I want to use my software tools. So let's just select the segment, and I want to show you how the construction tool works. So I selected it, I go to construct, and notice by what I selected, I have my choices are, I can do a perpendicular bisector, I can do a midpoint, I can do a regular, I'm missing something. So let's click off, and I want to show you also that you don't have to have something selected. You can actually choose the construction you want to do first, which in this case, especially if you're working with students, you don't want you want the software to help them, and I want to show you how that works. So I know that I want a parallel, so I'm going to look at parallel, and up here you'll notice it tells me what I need. I need to select a point and a segment. Well, I don't have a point, I only have a segment, so I don't have enough. That's why my selection the first time didn't work, because I didn't have the right thing selected. So I need to basically tell the program, well, I want you to be parallel here. So now I had to add a point in. So now let's select, let's go back, construct parallel. And again, it's telling me select a point. So I want my parallel to go through here, and I want it to be parallel to this segment. So the minute I hit this, it's going to do a parallel. And what I really like is it puts those parallel symbols in for me. That's really important when you're working with students, is marking things. If they're congruent, put the congruent marks. If they're parallel, put the parallel marks in. So it does put in the parallel for you. So now I have two parallels. So that's part of my problem, and I can make them be closer, further apart, but they're going to always stay parallel. So what's next? Well, parallelogram is a quadrilateral, so I need four sides. I only have the beginning of two sides. So I could get let's just get another straight edge, because students are working with straight edges, and I think we'll use this segment this time. I'm going to make a segment that connects these two, right? So this one's on that parallel line. So I'm almost there. Well, what's my next thing? Well, we already have that when opposite angles are congruent, opposite sides are parallel. So then I need another segment or ray, whatever, that's parallel to this one that I just added. So let's do construct again. And we want parallel again, so notice you can choose. And now I want to select a point. Well, where should my point be? Well, I have one point. I need a quadrilateral. I need 4 vertices. Well, here's 1, here's 2, here's 3. I'm missing this one up here. So I want my other parallel to go through this point. So that's the point I'm going to select. So I want the parallel to go through this point and be parallel. That's my segment to this side. So now I have if you look, I have my parallelogram, and I might want to put the construction intersection point there. So here is my parallelogram. I could get my polygon tool. So this is a polygon tool, and basically it colors in the inside. So I'm just going to follow my points and color in my parallelogram. So there's my parallelogram. And it's going to always stay a parallelogram because of the way I constructed it. I constructed it to always be parallel, so it's going to pass what we call the drag test. If you don't want to see these auxiliary lines, or what we call the parents of the parallelogram, they're the underlying constructs that I used, I could select them and choose. So notice I don't want these 2 lines. I don't want to delete them, because if I delete them, the parallelogram is dependent on them. So the whole parallelogram will go away. So I want to basically make them hidden. So I could either hide them this way, or I could make a hide show button, which is always nice when you're working with students, is if you create these types of things. So these are my lines. You can bring them back and forth when you want them to, when you're talking about, how things work. So that's how to construct a parallelogram, and that's how to use the parallel line. So basically the construction tools, if you look at them, if you click them, it tells you what you need. So this is a really nice feature because you don't necessarily have to show the students how to use all of them. It tells you what they need. They need a segment and 2 points, and so that was for a perpendicular bisector. So for a perpendicular, I need a 1 point and a segment. So basically constructions require at least 2 things usually. What is it you want to go through, and what do you want it to be parallel to or perpendicular to? So 2 things that you need to define. So let's do another, and we'll just leave the points on this time. So I want this time to do so I want an angle bisector. So it's telling me select 2 lines. So I'm going to select this line and this line, and it will make the angle bisector between that angle. If I clicked it down here, it would have done it down here. So notice it shows you what an angle bisector is. So all of these construction tools are basically programmed to get to the end result quickly, instead of what we did up here where we were doing all the circles. So if I did perpendicular bisector, I'll just show you the difference here, of a segment, it's going to get to this very quickly without doing all the circle stuff. I do perpendicular bisector. It says select the 2 points that you want to bisect or the segment you want, and there it is right there. So it skipped all of the circles. So in a sense, all of this has been done behind the scenes, and here's the end result. And notice as I mouse over it, you see that this line is a perpendicular bisector. It shows you the perpendicular, it shows you the congruent halves of the segment, that it's going through the midpoint. And Amy, what time? 7:15.
Yep, 15 more minutes.
Are there any questions, anything I should be, or does somebody want to see a specific construction?
No questions at the moment.
Okay.
One thing I do want to mention is you notice Karen has kind of continued to scroll, so it's one long page, so you can do a bunch of different constructions on the same page, or if you want, if you sign up for the free account, you can just click on the little button at the top that says new paper and get like a fresh sheet. It's like flipping, a page in the.
Oh yeah, maybe I should mention it. So I'm working in my account right now, so I know that because if you look over here, there's this little cloud. Classpad, if you are in your account, is auto-saving everything you do. So this paper is being saved in my papers, and I don't have to think about or remember to save stuff. So it's all saved here. I can come back to it any time, get rid of things, that type of thing. If you're in, I'll show you the difference. If you're in just as a guest, you don't have an account, the difference is a couple things. Might be a little slow right now. Oh, it thinks I'm still logged in.
Yeah.
Let me log out so that you can see the difference. All right, now I'm logged out. It doesn't know that I'm here. So the difference being, first you get this little note of what to do. There is no cloud because it's not saving because it doesn't know where to save to. So there is no autosave. There's also no opportunity to start a new paper because a new paper means you saved your other one. So if you're just in as a guest, everything you're doing is you still have unlimited scroll, but it's not going to save anything. So creating an account is important because then it's saving everything you do, and all your papers are over here. You have a whole paper management. You can create folders. We have previous webinars that kind of showed how to do that, and we're going to be talking about them in August as well. So yes, as Amy said, unlimited, and I'm focused on one thing, so I didn't go to different papers, but I could have. I usually
go back to that perpendicular bisector right there. There was a question on whether or not you can actually indicate or keep that indicator, because I know when you're hovering over the perpendicular bisector, it showed that it was perpendicular.
See, it doesn't. Oh, I think I'm logged in as Classpad. Hold on, it needs me to log in. Okay, so that's a great question. It doesn't stay that way unless you actually technically measure the angle. So right now, that's more of a reminder of what you constructed. But if you actually, because remember, constructions have to do with without actual measurements, right? So it's just showing you that this construction, I don't know why it's not letting me log in. All right, let's try. It's not going to let me do it. I think my computer has frozen. So if you actually wanted the right angle to show, you would actually have to, all right, my computer's obviously frozen. You would have to actually measure the angle. Because right now, this is just a construction, and it's reminding you of what you constructed. So if you wanted to see the right angle all the time, you would go into Measure. And, oh, I have the wrong thing selected. Select the two angles, and then it will actually keep it there automatically. And if you want to see now the congruent marks are never going to automatically are never going to be permanent unless you basically, it's considered like a decoration, I guess. It doesn't automatically put tick marks unless it's construction, but those will not stay unless you add a decoration, basically. So you'd have to
measure.
You'd have to have a point, and you could do, it's basically a decoration on the line.
Yeah. So, and you can use that so that the 90 degrees is always showing there.
Yeah, well, I measured. And
right.
So once you measure that, and this, I could hide if I don't want to see the 90 degrees, this is considered, so watch what happens. When I click this, my options are visible, and there's a couple things you can shut off. So you kind of get a lot with, oh my God. I don't know why it keeps doing that. So whenever you measure something, you kind of get a couple things. You get the measurement on the screen, which is great because if you move things, then it lets you see that on the screen. But if you don't like that, sometimes you don't like that, you can hide that. You also get an extra sticky here. And this sticky, everyone's like, why do we need that? Well, this sticky is basically an actual numerical value. I could change, well, I can't change that angle because it's constructed to be 90. But if I had just made a normal angle and measured it, I could actually change it up here and it would change in the screen. So this is sort of controlling the actual angle another way. Or it's also used if you want to do a calculation. So if you wanted to do, say, the sum of the three angles in a triangle, it would be here and you could use it from this measurement. And so it's considered a quantity that you can use in a calculation. So that's why you get like these different things. But if you don't like them, and it's not going to let me do this because
well, at least it goes to show you how often it's trying to autosave for you.
Yes, it's saving a lot and it's not happy with me. Would you log in already? But it won't let me log in. I don't know what the problem is. Any other questions? Because I'm looking at our time, we probably need to bring this to a close. But constructions are, you know, again, I always started my students actual hands-on compass straight edge and going through properties because it's just reinforcing the properties. And then when you get into the more specific things, you could still do them with a compass and a straight edge. It takes a little bit more because it's a lot of circles. But if you're going to use software, it's really about how do I, let's just think about a square here. Oh my God. I don't even know. Let me try this. Okay. So as we're waiting for this, somebody tell me how could we start? Think of constructions. How could we start with a square? There's so many ways you can construct a square. You can even use transformations, but let's just think about, you know, our basic constructions. So somebody give me, if I want to construct a square, what do I need? I need congruent sides, right? I need perpendiculars, right angles. Anything else? Parallel, right?
Yep.
So there's so many ways you could start. So this is such a great way to understand properties and use construction. So for me, one way, and this is one of my favorite ways, is to actually use a circle. And again, why are we using a circle? Well, because a circle has congruent measures in it. And I know that. So I'm going to use that to help me because it will help me get two of my sides. So here's one of my sides right away, one of the radii. And I know now, if I make another radius, I know it's congruent, but then I have the additional constraint that they have to be perpendicular. So I want a radius in this circle because I know it's congruent, but it has to be perpendicular to this side of the square. So how could I do that? Well, this is where you're going to use your construction tools. Your construction tools, and I know I need a perpendicular, not a bisector. And so it says you need a point and a segment. Well, which point and which segment? Well, I know I got to use this segment, right? So because that's my side. And which point should I use? Should I use point A or point B? Well, it doesn't matter. I could use either one or both. Actually, let's use both. So I'm going to click A first. There's my perpendicular. And then I'm going to do the same thing. I'm going to make another perpendicular, but this time I'm going to make it at B. So what have I done? I've made two perpendiculars, but what properties are happening right now? They're perpendicular to the same segment. So what's coming up right now? So who can see it? AB is really what to these two lines? Starts with a T. My geometry teachers, come on. All right, transversal. Thank you.
There you go.
This is a transversal. And so what do I know? I know that I have same side interior are supplementary, which means these two lines must be parallel. So guess what? By doing this, I just made my parallel, opposite sides are parallel thing. So now all I need is this last side, right? I know I have a point here. This is one of my vertices. So let's construct that intersection. And so now I need this fourth side, right? Right here. So how could I do it? Well, there's a couple ways I could do it. This is where it gets it's really exciting to see students really applying their properties, because there's so many ways to think about it. I could do a perpendicular to this line right here at point C, which would then be parallel to this one because they are, you know, alternate interior angles. All of those things happen. Or I could do a parallel to AB through C. So let's do that since we didn't do that. So I'm going to select those two things and I'm going to construct my parallel. And there is my square. So again, construct intersection. So there's my square, and I could use my polygon tool. I always like to use my polygon tool to highlight my end result. I don't have to do this, but it just looks nicer. And I could leave it like this, and if I were doing this with students, you know, I'd be dragging each vertex and making sure it stays a square. Do all the properties remain? Yes. But I don't like all this other stuff, so I could then have them hide everything that we don't want to see. So either by just going to visible and hiding the objects, that's one way, or making a hide and show button so that I can always see the underlying constructs that helped me create that square. And I would have my students do this, because then I know that they didn't actually just draw it. So there's my square. And I think we're almost done, right?
Yep.
All right, so let me switch back to, if I can figure out how to do that. Oh, there we go. All right, so we have lots of upcoming webinars. I think next week I'm actually working with some of the, in geometry again, but some of the ways to do 3D shapes. So we don't actually have a 3D component like a GeoGebra, but we have ways, we have different grids, isometric dot grids that allow you to do 3D shapes and show the nets and stuff. So I'm going to be working with that for next week. And then we're doing kind of the same idea with the CG 500 calculator. And then you'll notice that we're going to start talking about, I know school's about to start, so our August Classpad activities are kind of focused on how do you help students using technology? How could you teach with this? How could you organize your class and use technology in your classroom? Is sort of what our August, September webinars are focused on. And then I think there's another one. Oh, yes, this is very exciting. We are partnering with Todos and doing some equity and education webinars. So we are basically hosting, and there are guest speakers, and they're doing the presentations, and it's all about equity and education. So our first one is on August 4th. So you can find that information on the Todos website, on Twitter, on our website. So lots of places for you to go and explore those different webinars. We have 2 more that just got scheduled, so we're going to be adding to this series, but these are the first 2 that are coming up in the next couple of weeks. And I think that's it. Should we go to the next?
One more slide. Yeah, you can go to the next slide.
I'll let you finish up.
All right. Thanks, Karen. So thank you all for joining us tonight and being active in the chat panel and helping us with answering the questions that Karen has asked. We hope you guys were able to learn something new about Classpad.net and hopefully start getting a little bit excited about going back to school, whatever it looks like for you guys. As Karen mentioned, we are on social media, so feel free to check there for upcoming webinars or other events that are taking place, as well as all our previously recorded webinars, as well as other videos on our YouTube site. And if you are in need of a certificate of attendance, just feel free to email us at classpad.net@gmail.com, and we will be able to provide that for you, for those of you that joined us live.
Yes, really appreciate it. I love that people were actually communicating. It's very exciting for me. It's nice to ask a question and get answers. It's exciting.
Yes. So if that's...
And how, I would be curious to know, I can see all the text underneath. I'm curious to know how many mistakes it made in what I was saying.
There were a few at the beginning, I think. Just
Okay.
like it didn't translate Drexel University correctly.
Oh,
I did notice
interesting. Interesting. All right.
that.
Well, thank you very much, everyone. Really appreciate it. And hopefully you'll join us again for a future one. And I'll be sending the follow-up email tomorrow with the link to the recording.
Yes. Thank you guys so much. Good night.
Thank you. Have a great night.